All right, kids, we're going to do lesson 821. Let's find the sum of the interior angles of any polygon on Earth. We can do that. Here's the formula. N minus 2 times 180. Actually, the SAT, every once in a while, they'll use this formula, so keep this in mind. So this formula right there is going to find the sum of the interior angles of any polygon. So letter B, what's the sum of the interior angles of a hundredgon? Okay, well, actually, first of all, take a wild guess. What do you think N represents? That's right, the number of sides. It's self-explanatory, but I figured I'd just tell you. So the sum of the interior angles of a hundredgon. That must be a crazy looking shape. It's got 100 sides. So all we do, let's use the formula, N minus 2 times 180. Okay, I'll bust out my eraser. We can get rid of N, and we're going to substitute. And I'll use a different color so you can see the substitution, 100. And that is going to equal, you pop that in the calculator, trust me, you're going to get 17,640 degrees. Okay? Well, what if we want to find the measure of one interior angle of a regular polygon? So in this case, it's got to be a regular polygon. Okay? Well, what's the formula for that? Well, it's going to be our same formula. If we find the sum of all the angles, all you got to do is divide by the number of angles or sides, and that's going to give us one of the angles. Okay, so let's do a nonagon. Well, a nonagon has 9 sides. Okay, so what do? To find one of the angles, N minus 2 times 180, so in this case it's 9 minus 2 divided by, you guessed it, 9. You run that into the calculator and you're going to get 140 degrees. Okay, how about a hundogon? Well, it's 100 minus 2 times 180 divided by 100, and that's going to equal 176.4 degrees. Ooh, okay. Well, how about an exterior angle? Let me zoom up a little, and I'm going to try and draw a regular, maybe a hexagon. Those are kind of easy to draw. Not bad. Okay. Well, watch what happens when I try and find an exterior angle. If I extend these angles here, or these sides, I'm going to create exterior angles. So here's an exterior angle here, here, and guess what? They are all the exact same. So if I have 6 sides, obviously I'm going to have 6 exterior angles. So these are examples of exterior angles. Okay? Well, there's a formula to find the measure of one exterior angle of any regular n-gon, in other words, any regular polygon on Earth, and that formula is simply 360 degrees divided by n, where n is the number of sides. Okay? So, can we find an equilateral triangle, each exterior angle? I think we can, but first, let me just draw one. Okay, and then if I come in here and extend, try to do a dotted line, then these right here are exterior angles. There's 3 of them. They're all the same. So the formula is 360 divided by number of sides, which is 3. So each of these angles right there, 120 degrees. How about a regular octagon? Let me just draw one more time because some of you might start drawing some conclusions here. That's not bad. Okay, if I extend these out, you'll notice the angles are getting smaller, but there's more of them. But again, what's the formula? 360 divided by 8 sides in an octagon, 45 degrees each. Okay? I'm going to slide over, polish off these last 2, a regular decagon. Okay, I'm not going to try and draw that one. But what do? 360 divided by 10 sides. Each exterior angle is 36 degrees. And last but not least, the dodecagon has 12 sides. Okay, let's mix up the color here. So we could take 360 divided by 12. You can use a calculator, 30 degrees. One final thing. It's not on here, so maybe I'll do it down here. Letter E wants to know what is going to be the sum of the exterior angles, no matter how many sides, okay, well, I'll put in big red. It's always, I love math because a lot of times you can say always equal to 360 degrees. In other words, no matter what the shape is, if I add up the exterior angles, if it's a regular polygon, it's always going to be, or really any regular n-gon, going to be 360 degrees. Take a break.